Hello everyone, it's Lena once again. In this video I will give you a brief introduction to assignment 2 of the ESP course. So in assignment 2 you will program an elevator simulation program. So your task is to simulate the operation of elevators in a hotel. So for this, first you need to get some user inputs. You need to get the name of the hotel, the number of floors the hotel has, the number of elevators the hotel has, the capacity of each of the elevators, which is the same for all elevators, and some information about the guests waiting for the elevators. And then once you've got all these inputs, you will simulate the movements of the elevators and the guests following a given procedure. And in the end, you count how many steps the simulation takes for all guests to reach their destination floors. The deadline for this assignment is the 6th of December at midnight once again, and it's worth 24 points. A little bit about the specifications. So the general specifications on the course website are valid once again, the ones you used for A1, but now also the section on memory management is relevant, so take a look at that if you haven't yet. There are also 2 additional specifications for assignment 2 specifically. One is that you must not use the string.h library, you're not allowed to use that. So you need some functionality to work with strings in assignment 2, and you need to write this functionality yourself and are not allowed to use this library. The second specification is that malloc or calloc, if you like that better, and free must be used. So for your simulation to work, you need to create some arrays to store your data. And all these integer arrays whose size depends on the user input. So it depends on the number of floors, it depends on the number of guests, etc. All these arrays must be stored on the heap. So please take care to follow those 2 additional specifications. Now I will explain to you a brief example. This is just an example so that you have an easier time reading the assignment description. So it's just an example to explain the sequence of events. You still need to look at the assignment description for which configurations of the hotel are valid, a detailed description of the algorithm, and how the following images translate to ASCII output, and also which states of the hotel should be printed and when. So for our example, we will use the following setup. So the name of our hotel is pretty simple, it's hotel. The hotel has 3 floors. It has 1 elevator, which has a capacity to fit 2 people. And there is 1 person waiting on each floor. So in this illustration, you can see the initial state of the hotel and the elevators. So you can see that the floors are numbered from bottom to top here. It starts with 0, then here we have floor 1 and floor 2, and the elevators are numbered from left to right. In this case, we only have 1 elevator, so this is elevator 0, but if we had multiple elevators, it would continue this way. And even numbered elevators start on the ground floor going up, and odd numbered elevators start on the top floor going down. So in this case, we have elevator 0, which is an even number, so this one starts at the ground floor going up. And now here we have the waiting people, the guests, and the number above the person in this case represents the destination floor. So this person wants to go to floor 2, this person wants to go to floor 0, and this person also wants to go to floor 0. So we will now start our algorithm. So we start with people who have reached their destination leave the elevators. In this case, there are no people in the elevator, so nothing happens here. The next step is people who want to go in the current direction of the elevators enter. So you can see here, This person wants to go to floor 2, which is upwards. The elevator is currently going upwards, so this person enters the elevator. And here we've put a placeholder that marks the spot where the person has left. The next step is that the elevators move one floor in the current direction. So the elevator was here, it moves one floor in the current direction, which is upwards. Next, we check if the elevator is now on the top or the bottom floor, it changes direction. In this case, it's not, so nothing happens. And now we start again from the beginning of our sequence. So people who have reached their destination leave the elevators. This person has not reached their destination, so they stay in the elevator. So nothing happens here. People who want to go in the current direction of the elevators enter. This waiting person here wants to go to floor 0, which would be going downwards. The elevator is currently going upwards, so this person will not enter the elevator. So in this case, nothing happens here. The elevators move one floor in the current direction. As you can see here, the elevator has moved one floor upwards from floor 1 to floor 2. Next step, if an elevator is now on the ground or top floor, it changes direction. So now that the elevator is on floor 2, which is the highest floor in the hotel, the direction changes from upwards to downwards. And once again, we start from the beginning of our sequence. So we check if people have reached a destination. The destination of this person who was here was floor 2, so this person leaves the elevator. And this also means that the person leaves our simulation. We don't need this person anymore. The next step, people who want to go in the current direction of the elevators enter. This person wants to go to floor 0, which is downwards. The elevator is currently going downwards, so this person enters. We once again put a placeholder marker here. And the elevator moves one floor. Elevator has moved one floor from floor 2 to floor 1. Once again, we check if we need to change the direction. We don't need to do that here, so nothing happens. We check if people want to leave the elevator. This person has not reached their destination, so nothing happens. And now we check if people want to enter the elevator. This person also wants to go to floor 0, so this person also enters the elevator because there was still one space left, because we said earlier that our elevators have capacity 2. If the elevator would have been full, this person could not have entered the elevator in this step. But in this case, there was a free spot, so this person enters. We once again put a placeholder here. And once again, the elevator moves one floor from floor 1 to floor 0. It's now on the ground floor, so it changes direction. And we start again from the top of the sequence. We check if people want to leave the elevator. Both those people had their destination floor set to 0. So both those people leave the elevator, leave the simulation. And now that nobody's waiting anymore and all elevators are empty, the simulation ends immediately. So that's our final state. So this was an example where I showed you all the intermediate steps. So not all of these steps will be printed by your program, but this is just an example to see what happens internally. So now we will look at a second example, which we call example B, which is the same as example 2 from the example outputs in the assignment description. And in this case, I will only show you the states that will actually be printed by a program. No intermediate states will be shown. So now we use a different configuration. The hotel is still called hotel. We still have 3 floors, but now we have 2 elevators, each with a capacity 1. And we have got 2 people waiting per floor. So this is our initial state. As you can see, we've got the 2 elevators, elevator 0 and elevator 1. and we've got 2 people waiting on each floor. The number of people waiting on each floor is always the same for all floors. So, and also the waiting people are sorted by the destination floors in the output. So in the user input, I can put the destination floors in any order, and you then need to sort them so that in the output they will appear sorted by the destination floors. So we will take a look at the first step. So we've got, nobody has left the elevators because nobody was in there, but people have entered the elevators. So in this case, we had 1 person who wanted to go to floor 1 and 1 person who wanted to go to floor 0. So, and only 1 person can fit in the elevator because we have capacity 1. To decide which person enters first is, we check who has the shortest distance to their destination. So in this case, this person would have a distance of 1 floor. This person would have a distance of 2 floors because they want to go down here. So the person with the shortest distance enters first. So now we've put those 2 people in our elevators. Same thing happened down here. And now we've got placeholders here once again. And as I mentioned earlier, the list of waiting people is always sorted by the destination floors, with the placeholders for empty spots being at the beginning of the list. So earlier we had this 0 person here in the front, but now that this person has left, this placeholder is in the front and the 0 person moves back. So looking at our next step, the elevators have moved 1 floor in their current direction, and both the people who were in the elevators earlier had destination floor 1, so they leave here. And the people waiting here had destination floor 2 and destination floor 0. So they each enter the elevator that is going in the direction they want to go. Next, the elevators once again move 1 floor in the current direction. Then all elevators have reached the end of their path, so either the top or the ground floor. So all elevators change their direction. The people in the elevators had destination floor 2 and destination floor 0 down here, so those 2 people have left the elevators, and the waiting people have entered those 2 elevators. Next, the elevators once again move 1 floor in their current direction. Nothing else happens here. Then once again, the elevators move 1 floor in their current direction. Now we once again have reached the end of the paths of the elevators, so all elevators change their direction, and the people in the elevators have reached their destination floors. So both those people leave the elevators, which means that all elevators are empty. There are no more waiting people, so the simulation ends immediately, and this is our final state. So that's it for the examples. If you have any questions, please ask them via Discord in the A2 forum. There will also be another question hour, which is currently planned for the 4th of December. And I will now show you just quickly for the end of this video what an execution of this program, of a working program, would look like. So I will start the program with make run. So you get some header output, then you need to read some user input. So in our case, we said our hotel is just called hotel. We want a number of floors in the hotel. For example, we have got 3 floors. Next, we need to input the number of elevators in the hotel. Let's go with 2 again. Next, the capacity of the elevators. So let's just use our example from earlier. So capacity 1, and the number of people waiting on each floor will be 2. So now we need to enter the destination floors of all the waiting people. So first we enter the destination floors of the people waiting on floor 0, which is entered as a list of integers that are separated by a comma. So in this case, I have got 2 people waiting, so I need to put 2 destination floors. So yeah, and then we do the same for floor 1. As I mentioned earlier, it doesn't matter in which order you put the destination floors in the input, because you need to sort them internally in your program. So, and now we need to do destination floors for the final floor. All right, so now we've got all our user input. Then the program will ask us if we want to see this setup in an image. So I will say yes. And here we can see our hotel. Looks a little bit different than the images, but I hope you can imagine how this corresponds. Here we've got the name. Here we've got the list of waiting people on each floor. And this number in here means how many people are in the elevator. That's the difference to the images I showed you earlier. In the later steps, you will see that where the people are going in who are in the elevator will be output as a list below this image. So I will show you this right now. It's gonna ask me if I want to start the simulation. If I enter skip here, the program will just end. But I want to start a simulation because I want to show you. And then you have the option to either show all steps, which is all the steps in the second example I showed you, or just the end result, which it just shows you the final state. But in this case, we now want to see all steps. And then the program will go through and do the simulation and then terminate. So we will now take a look at one of these steps. For example, let's take a look at the first step. Got here simulation step 1. Once again, we've got our hotel here and the waiting people, but some people have entered the elevator. So we know this here means that one person is in the elevator, and this here means that one person is in this elevator. And below the image, we can see where the people in each elevator are going. So in elevator 0, which is this one, the person wants to go to floor 1. And in elevator 1, the person wants to go to floor 1. Let's take a look at another example, maybe this one here. So once again, we've got one person in each elevator, but now the person in elevator 0 wants to go to floor 2. This is that person here. And the person in elevator 1 wants to go to floor 0. This is that person here. So you can see how this corresponds to the images I showed you in the slides. And this simulation goes through, outputs all the steps. If you choose to output all steps, then finally we reach the final state, and we've got an output how many steps it took, and the program is done. So I hope this helps you with your implementation of assignment 2. As I said, if you have any questions, feel free to ask on Discord or at the question hour, and I wish you good luck. Bye everyone.